Vertical projectile motion, Part 2, Calculations and Explanations. VPM is usually question 3 on your physics paper, and most of the time people struggle with it. However, these are the equations that you'll find in your datasheet. Vf, velocity final, Vi, velocity initial, acceleration, and time. Using these equations and keeping track of what you're doing, you'll get the correct answer no matter what. To improve your VPM, you need to do more examples. So we'll be doing a past paper example. A ball is thrown vertically upwards from the top of a building of height 25 meters with a velocity of 12. On its way down, the ball passes a door which has a height of 1.9 meters and then strikes the ground as shown in the diagram below. Ignore the effects of air friction. They have already filled in the diagram for you, which is nice so you can see what is happening. Calculate the time taken for the ball to reach its maximum height. V final is at the top here at its maximum height, and V final you always know is 0. So you sub it into the equation. Here we're taking upwards as positive. Velocity final is 0 because it's at its maximum point. We're taking upwards as positive, so your acceleration will be down, so it will be negative 9.8. Your 12 is given, and now you're solving for your time, which is simple substitution. The next question, velocity with which the ball strikes the ground. So we're working out the velocity here. Again, you substitute everything into the equation. This is your velocity final, which we're working out. Your 12 is what we had, your negative 9.8, because we're taking upwards as positive, and your height will be negative, because we're taking upwards as positive. Here is your height, which you just sub in, and now you solve for your final velocity. Don't forget to square root your answer to get it alone. The next question, calculate the time it took the ball to move from the top of the door to the ground, which is here to here. The first thing, you work out what your velocity final will be at this point. You substitute your 12, you substitute your negative 9.8, and then your 23.1. That's the trick in this equation. They give you the 1.9, they give you the 25. You need to subtract the distances, which will give you your final velocity. Then you have to work out the time of that, and you just substitute everything in this equation to here and solve for your time. Let's do another example. Ball A is thrown vertically upwards from the top of a balcony overlooking the street. It leaves the thrower's hand at a velocity of 5, and it hits the street below the balcony. At the same instant, ball A is thrown, ball B is thrown upwards from the street. Ball B leaves the thrower's hand at a velocity of 8. What is meant by projectile? This is a theory question which you can get from your exam guidelines. Projectile, an object upon which the only force acting is the force of gravity. Calculate the time taken by ball A to reach its maximum height. Maximum height is over here. So this is simple, just substitute in the equation. Velocity final is 0, which is here. Your initial is here. And then negative 9.8 because we're choosing upwards as positive. And you're solving for time. The next one, calculate the velocity of ball B at the moment ball A is at its maximum height. Here's its maximum height. So we're using the time. We substitute this time into this equation and we solve for velocity final, taking 8 as initial because they tell you it's 8 and negative 9.8 because we're taking upwards as positive. The next, after how many seconds will the magnitudes of the velocities of the two balls be equal? We say ball A. We have to do simultaneous equation here. Ball A, we're solving for time. Ball B, we're solving for time. However, ball A is moving downwards, so we need to put a negative in this place. And ball B is moving upwards, we take an upwards as positive, so that's all sorted. Now we just use simultaneous equations and make them equal, and you solve for time. The next question, use your answer in question 3.4, determine the height of ball A from its starting point. Now, we use this answer and sub it into this equation. It clearly says question 3.4. So take note to use the above answer. You have your 5 as your initial, your 0.66 as year, and then you sub it in both places and you solve for your distance. It can either be delta y or delta x. The last example is a simple one, which is why I want you to pause the video and attempt it yourself before going through the answer together. A boy standing on top of an 80-meter high building throws a ball vertically upwards. The ball is thrown from the boy's midriff position. It takes the ball 6 seconds to land on the ground below. The first question, what is the velocity of the ball at the maximum height of its motion? Just remember the ball's motion is like this. Thus we know that the answer would be 0. Calculate the magnitude of the initial velocity of the ball. We have everything and we taken upwards as positive. We have the height, we have the time, and acceleration is negative, and we just solve for velocity initial. Calculate the magnitude of the final velocity with which the ball strikes the ground. Again, we have everything and we just worked out the velocity initial. We substitute the initial, we have the time, and then your acceleration's negative. Thus, we just solve.